Yesterday we talked about the theoretical yield as when we took the limiting reactant, so how much of it you actually use up, and we converted to how much product we're actually going to produce, or we think we should produce. That was called the theoretical yield. So that's the maximum that we could produce. But then when you go to the lab and you actually do the experiment, a lot of times most reactions are not 100% efficient, so you really don't get as much product as you should. And so our efficiency we will calculate using the percent yield. So the actual yield is what you would actually measure if you did the experiment and did the reaction. So to find our percent yield, you take the actual yield, which is what you would actually measure, divided by the theoretical yield. The theoretical yield is always when you do a conversion and you convert from your limiting reactant over to your product. That's your theoretical yield times 100 to get it to be a percentage. So like on number 5 on your worksheet, I think it says there's 11.3 grams that you actually produce. That would be your actual yield. Your theoretical yield, that's the actual yield of sodium chloride. So the theoretical yield you actually already calculated in number 3, because number 3 you converted, no, in number 3, because you're calculating how much sodium chloride can be formed. That would be your theoretical yield of sodium chloride. That's how much, that's the maximum amount that you would form. But it says in lab you actually only produce 11.3 grams. So you have your actual yield is 11.3, and then your theoretical yield is whatever you got in number 3, and then you times by 100 to get your percent. So the percent yield equation is in itself is pretty simple, but finding the numbers will be a little more difficult. Yes. Actual divided by theoretical. Chlorobenzene is used in the production of many important chemicals such as aspirin and disinfectants. Now, isn't that a little, yeah, sketchy that you're ingesting aspirin, but you probably don't want to ingest the disinfectants, but it's made from the same thing. Okay, but it does go through several different processes. One industrial method of preparing chlorobenzene is to react benzene with chlorine, which is in this reaction. Is that balanced? 6 carbons, 6 hydrogens, and 2 chlorines. Yep, balanced. So it's all 1-to-1 ratios. That will make that part a little easier. So when 36.8 grams of C6H6, so let's write 36.8 under here, with excess chlorine. So which one's our limiting reactant? Right, C6H6, because it tells us that chlorine's in excess. We don't have to worry about how much chlorine. So we don't have to calculate which one's limiting. It gives us 6. Excess one is chlorine. Okay, the actual yield is 38.8 grams of C6. So if we have actual over theoretical, let's put the 38.8 grams, because it's asking for percent error, or percent yield. What would be our theoretical? Okay, so this is the actual yield of C6H6Cl. So we need to find the theoretical yield. So we need to do a conversion here. And we need to convert 36.8 grams of C6H6 to how many grams of C6H5Cl. So we want to start with 36.8 grams. So carbon's 12.01 times 6 plus 1.01 times 6 is and that's the mass of 1 mole. Okay. Those cancel out. What's our next step? Y1. Yep, that's the coefficient. And we're converting to C6H5Cl. And the coefficient is 1 as well, so we have 1-to-1. Cancels. And the last step we need to convert, oh, this is mole. The mass of 1 mole of C6H5Cl. Chlorine is 35.45. 45. 35.45. That sounds right from the previous classes. Okay, so that will give us our theoretical yield. That will give us the maximum amount of C6H5Cl, chlorobenzene, that we can produce. And I think it's 53 something. I don't remember. Yeah, multiply the top and divide by the bottom. Yeah, that's 70. Ooh, I don't know if I... Oops, that's the wrong... Okay. C6H5Cl. Okay, so that's our theoretical yield. So we're going to put that in the denominator. So we're going to have... Yeah, the test will mostly be problems on this one. Oh, come on. This is really fighting. Okay. So what'd you get? 73%? Point what? 18%. Right. That sounds right. So our percent yield, so it's 73.18% efficient. That's our percent yield. So really we're not adding any other converting. We're not converting anything differently. We're just using that information. Now we're actually using the information to give us some sort of data. I think on your worksheet they give you all the actual yields. Right, you'll always have to calculate theoretical yield. Make sure they're both the same compound. We couldn't have like 36.8 over 38 because they're different compounds. We have one more. Because another way you can use the percent yield equation is maybe they will give you how efficient it is. They give you the percentage, and then you have to figure out what the actual yield be, which is this case where you have 86.7% efficient. How much SO2 should be expected if 4,897 grams of zinc sulfide are used? So we're going to be able to calculate the theoretical yield of SO2, and then we're going to want to find what the A is. So we're going to have A, we're going to solve for A, over, we need to figure out the theoretical, so we can't use 4897 because that is not SO2, right? We need how many grams of SO2. So we need to convert the 4897 into grams of SO2. Zinc is 65.39 and sulfur is 32.07. Someone can figure out that mass. 65.39 plus 32.07. Okay, so there's our mass. And now we're going mole to mole, so we need to use our coefficients. So 2 moles of ZnS. It's a 2 to 2 ratio, which the 2's cancel out if you want. And then we use the mass of SO2, 2 grams, which is 64.07. Because it's 2 times 16 is 32 plus 32.07. So it's 64.07. So this is how much sulfur dioxide can be produced. That's the maximum, the theoretical yield. How much should be produced, but we're not 100% efficient, so we're not actually going to get that much. Am I right? It's 3. Right. Whenever you do this conversion part, it's always theoretical. I think it should be 3,000 something. And really the 2's cancel, so you could not include the 2's, but you can. .42. So we're going to use that as our theoretical. So 3, 3, 2, 1. Someone else get that number? And our percentage they give us is 86.78. Just remember that number from previous. But sure could be. Yeah, that sounds, I remember that number. $3,219. Okay. So if I want to solve for A in this equation, what am I going to do first? Right, I'm going to divide both sides by 100. That way this cancels. So I'm going to have A over 3219.28 equal to 0.8678. Then how do I solve for A? Multiply by the 3,219.28. So at my actual yield, I get that's a 6. Questions? Okay.